Hello students, good morning. So welcome back to the class. If you have gone through the watch the videos, then definitely you must be knowing that I have started with a fresh new chapter, right? And the chapter, of course, chapter 3, elements, compounds and mixtures. So in the previous class, I started with this chapter, new chapter. Probably you must have thinking that with the same states of matter, physical and chemical changes, probably you must be learning from these two regarding these two chapters from class 6, if maybe possible, and 7, of course. So for that reason, it will give you a break, thinking of that perspective that let's change it a bit towards something new, where some interesting thing will come up and relate it more closer to the subject of chemistry. So in the previous class, I started with this chapter, and as the name suggests, elements, compounds and mixtures. So let's do a very quick recapitulations that what I did, so that when I'll continue with this with the second part of this chapter, so you can be able to connect with that one, the previous one and the upcoming one. So the previous one I started with the substance, that what a substance is, the types of substances, if you remember, that is pure substance and impure substance. And under the pure substance, it was classified, or rather it was said that pure substances are elements and compounds, of course, and impure substances are basically categorized under the mixture section. So pure substances, under the category pure substance, we were having that elements and compounds, and I also discussed regarding what is an element. That was discussed previously, if you remember, and I hope that you were remembering that one, that we are already discussed about the definition of elements and what are the properties of elements, some of the various examples of elements. We have discussed those things, right? Now, further, it was also discussed that elements can also be further classified. Elements can also be further classified, and that the classification of elements were also discussed. And if you remember, that was it was discussed that elements are having 4 classifications in the name of metals, non-metals, metalloids and inert gases, of course. So elements, compounds, mixtures, and elements are classified as metals, non-metals, metalloids and inert gases. Some of the properties we discussed of all the individual classes, followed by the relevant examples also. So with that, those things, the previous class went over, and I stopped over there up till the classification of elements and discussing the properties of the different classes of elements. So today, once again, I will be starting from that particular point, of course, that where we stopped in the previous class. So I will start today's class from that particular point. All right? So from that particular point, I'm going to start today's lecture. So the last lecture, the previous lecture rather, stopped at elements classification. And if you remember, what was the classification? Metals, non-metals, metalloids, inert gas. Right? Some of the properties we have already discussed. So these properties we already discussed in the previous class. Have luster, mostly solids, ductile and malleable. So let's once again recapitulate that one, that is these terms. Some of the terms are maybe new to you. Luster. This word luster it's written have luster, but please, under when you will be writing the answers for these questions, please do not write like this way. Please do not write like this way. Okay, so they are having luster. So luster, this word means shine. So metals, if you would just go through the list, there are many metals are available, are present in our nature. So different metals. Now the metals, these metals are having luster, means the surface of these metals are very shiny. Shiny means it reflects light. So they are very shiny, it reflects light. So a very closer, better way to explain that is, it's so shiny, it's so much, it can reflect so much of light that sometimes these metal surfaces can also act as mirrors. Yes, of course, mirrors. So you can see your own face, yourself, particularly around yourself, getting reflected on the surface of a metal. So that's the property of the metals, that it is having luster, it's very shiny. And this shiny surface, it is capable of reflecting light. This shiny surface can be made shiny to so much extent that it can act as mirrors sometimes. Though definitely, I'll not say that it can replace mirrors, of course not, but it can act as mirrors. You must have noticed, if I'm not wrong, you must have noticed that suppose you have bought new utensils. Utensils are made up of metals, of course we know that. Utensils are made up of metals. So whether it's a copper plate, or whether it's a steel plate, or any sort of buckets, or any sort of containers, new one, over there we can see it's so shiny that we can see our own self, reflection of not only us or anything getting reflected on that surface. So that is what we call as luster. Clear? Okay. Moving to the next, that mostly solids. We know that we are rather habituated, or rather we will see that metals, they mostly occur in nature in the form of solids. We are aware that there are three states of matter: solids, liquids, and gases. Now these metals, they mostly exist in the solid state. There are very few, almost negligible number of metals existing in the liquid state. Okay, so metals, they are mostly solids. All right. The next, we are having ductile and malleable. It's the two words are just written. It's not a full frame sentence that's been written over here. It's just for an explanation purpose. So I'll request you, please do not write like this way in the examination papers, or when you are writing answers of a particular question related to this. Rather, metals and non-metals, or metals or metalloids, or any other, these differences or properties, or just metal properties of metals. So please do not write sentences like this way. It's not a basically sentence, it's basically two words just written. So ductile and malleable. Metals, they show the property of ductility. What does ductility means? This word ductility comes from the word ductile, meaning metals can be drawn into thin wires. Okay? Metals can be drawn into thin wires. Very thin wires. You have seen wires, electrical wires, so you can see how much thin it is. So metals, since they're ductile, so they can be drawn into thin wires. And what about being malleable? They can be drawn into thin sheets. So they can be drawn into thin sheets. So ductile and malleable. So metals, they can be converted. That's their property. That means when they are made to convert them, when they are getting converted into that particular wires or malleable, sheets. So they do not break. They do not break into pieces, small pieces. So that's the property of metals. So they are capable of, or they are having the property that they can be drawn into thin wires, long thin wires, as well as they can also be converted into thin sheets. All right? Okay. Let us go to some of the examples now based on this property. Apart from these properties, yes, as you can clearly see, there is a sheet. There's a metallic sheet. So metals can be converted into metallic sheets. Now please do not consider that metals. Please don't think that metals are red. No, this metal, it's basically being coated. This metal is having a paint. It's iron sheet basically. It's an iron sheet, but iron is not having this red color. It is basically having an external coat. This iron sheet is having an external coat, which for which it is being shown as red color, but otherwise iron is having silvery color. In previous lectures also, if you follow, I have told this one that iron is having silvery color, silvery color, or silvery shiny surface, right? That's the color of iron. Thin wires, as you can see, this is basically copper. So you can see how much thin it is. It's very thin. So that's the property of metals, being ductile and also being malleable. The next we are having non-metals. We have discussed this one previously also. That no luster, that means non-metals are not having a very shiny surface. Non-metals are not having very shiny surface. They're having only blunt surface. It's not very shiny. It doesn't attract easily people. It doesn't attract easily. So it is a very shiny surface. It is not having a very shiny surface. The next can be solids, liquids, and gases. So as we mentioned, we stated for the solids that it is mostly, for the metals that it's mostly solids. For the non-metals, we are classifying, or we are stating that non-metals, they can be solid, they can be liquid, as well as they can be gaseous. If I consider solids, then carbon, sulfur, these are non-metals. Phosphorus, these are non-metals, and these are purely solids. These are purely solids. What about liquid non-metals? Yes, of course, we are having liquid non-metal. That's bromine. Bromine is liquid non-metal. Then gaseous, of course, gaseous, lots and lots. Gaseous non-metal, of course, it's oxygen, nitrogen. Then we are having fluorine, chlorine. So many. Hydrogen, helium. So all these are non-metals, and they are in the gaseous state. Okay. Carbon, sulfur, as you can see, solids, examples. The next, metalloids, properties. That means, as you can see by the word metalloids. Metalloids. The word itself says it's a combination of metals as well as non-metals. So these substances, they're basically will have, not all rather, do not think that they will be having all the properties of metals. Then if that would have happened, then this classification wouldn't have existed. That means they will be having some of the properties of metals and some of the properties of non-metals. So both, it's a combination. It's basically a combination of metals and non-metals. What's next? Or rather, for example, arsenic, silicon, boron, these are basically metalloids. These are basically metalloids. They exhibit the properties, some of the properties of metals and some of the properties of non-metals. For example, over here, but specifically, let's consider silicon. Let us consider silicon. Silicon is, if it becomes non-metal, then non-metals do not conduct electricity and heat. As it's written over here, you can see that it's a bad conductor of heat. Similarly, bad conductors of heat as well as bad conductor of electricity. Right? Bad conductor of heat as well as bad conductor of electricity. Now, silicon is being a non-metal. Silicon being a non-metal, it shows the properties of non-metals as well as metals. How? The silicon conducts electricity. If you know about heard about computer chips, the circuit boards of computers and other electronic devices, those circuit boards, the wires, everything is made up of silicon. Why? Because if they would have used copper or iron or anything else, then huge amount of current would have passed through. But if so much amount of current would have passed through, then definitely the instrument or the machine would have got damaged. And hence, for that reason, these electronic modern devices, these are being made by using silicon wires, because silicon allows very less amount of current, and that less amount of current is only necessary to control the entire machine. Clear? Okay. Coming to the next, we are having non-reactive chemically, which are the inert gases. Inert gases, they're not at all reactive in nature. They're very inert. That means doesn't react easily, or some other inert gases, they do not have compounds. Some are having that. That is basically due to some. They're mostly non-reactive, but sometimes under situations or conditions, it reacts. The next, gases found in trace amounts in nature. So these gases, these noble inert or noble gases, these gases are mostly found or in trace amounts in nature. Trace means very less amount. Xenon 131. Now, the next we are having elements classification. Another point that went missing in the previous lecture, that was they are sonorous. Metals metals show the property of sonority. Sonority means metals produces sound when struck by another hard surface. So metals, they produce sound, distinct sound. Metals, they produce distinct sound when they are being beaten or struck out with another metal or hard surface. But with non-metals, such situation do not take place. That they are not sonorous. Metal is also the same thing, and inert gases are also the same thing. Now, there are certain exceptions to these situations. What's the exception? That is, sodium is a soft metal. Sodium is a soft metal. We are aware of that, the fact that metals, they're mostly hard in nature. Metals, they are mostly hard in nature. They are very tough solids. Okay? But sodium is an exception to this metal list. Sodium is an exception to this metal list. Sodium is a soft metal, and hence for this reason sodium can be cut down by a knife. The next, mercury is liquid. As I said before, that non-metals or other metals are mostly solids for that reason. Mercury is the only liquid metal. Mercury is the only liquid metal. The next, zinc is brittle. As I said in the previous, that's zinc. For example, zinc, it is brittle. That means if you hammer or if you beat up piece of zinc, then it will break down into fine pieces, right? Into pieces. That's called the brittle nature of substances that can be broken down. It breaks easily. Okay? But we know metals, they do not break easily. They are very, very hard in nature. They are hard solids. But for that reason, that's an exception. Tungsten conducts poor electricity. Tungsten, it's a metal, so it should have conducted a smooth flow to electricity, but unfortunately it doesn't. Tungsten doesn't allow a smooth flow of electricity. As you can see, sodium metal, it can be cut down by the help of a knife. You can see mercury, liquid mercury. The droplets of mercury metal is lying over there. Now iodine, for non-metals, iodine and graphite are lustrous. Carbon fiber is ductile. Diamond is the hardest substance known. Diamond is the hardest substance known. Graphite conducts electricity. So all these points, points are basically exceptions to non-metals as well as to metals. So iodine, you can see over here, this is iodine crystals, and you can see the solid is having a shiny surface. So it is having luster. It's having luster. Next is graphite. With this one, you can also see that the surface of graphite is a bit shiny. The next is this. These are carbon fiber. Okay, as you can see, a very meshy network of carbon fiber, a threads-like substance, a carbon fiber. Carbon fiber is ductile. Carbon fiber is ductile. Very thread-like things. That means fibers, long, thin thread-like things can be made from carbon fibers, more similar to metals. The next we are having compounds. Now what is a compound? The compound is a pure substance composed of two or more elements combined chemically in a definite proportion by mass. Now what is a compound? Once again I repeat. So compound is a pure substance made by two or more elements. Now of course, when you are preparing a substance, from two pure substance, then definitely your surrounding and the entire thing, everything, or the substance, everything will be pure. So a compound is a pure substance. That means it's deficient of purity, impurities. Composed of two or more elements, so a compound can have multiple elements, minimum two, maximum doesn't matter. Combined chemically by a definite proportion by mass. That means when those 2 or 3 or 4 or 5 substances are mixing together chemically, then it is being done in a definite proportion. That means this particular amount of the substance will react with this particular amount of substance, and hence it will form a compound. So it's basically a definite proportion by mass. It is basically a definite proportion by mass. For example, examples of course, water is an example. Ammonia is an example of compound. Sodium hydroxide is an example of compound. Then hydrochloric acid, once again, compound. So the list of compounds will go on. Hundreds and thousands of lists are there. Okay. So the list goes on. Water, we know that water is H2O. So 2 hydrogen and 1 oxygen. We are having ammonia, the symbolical NH3. So 3 hydrogen atoms and 1 nitrogen atom. Sodium hydroxide, that is NaOH. The formula is NaOH, sodium hydroxide, and that is also being rather formed by a definite proportion by mass. The next, hydrochloric acid, that's also another one, hydrogen and chlorine. Now the middle lines, you may think or you may ask that, so what the middle line is? We are showing us the compounds, along with the formulas of the compounds. But there are certain lines. When the two balls are there are certain lines. What are those? Those lines between the two balls are basically representing bonds. Between the two atoms. Bond between the two atoms of the elements. Now the next we are coming to properties of compounds. The first is atoms of elements, they will combine together in a fixed proportion by mass. That's the first criteria. That is, atoms of compounds, they are formed by a fixed ratio, or rather in a fixed ratio by mass. So when two substances are combining together to form a new one, then definitely there has to be certain things which need to be fixed out, and hence the best thing will come out from there. The next property we are having, they are pure and homogeneous. We know that the compounds are pure. For that reason, it was classified under the pure substance section. And they're homogeneous. That also we remember. Homogeneous means uniformity. So throughout the substance, we will get, suppose let's consider water or carbon dioxide. If a big chunk of water or carbon dioxide is taken, then it will be seen that they're homogeneous. That means from the top to the bottom, from the bottom to the top, and toward the corners of the of the substance itself, everywhere the same mass ratio is being maintained. There is no difference. So everywhere the same mass ratio. The third point is the compounds are having different chemical and physical properties with respect to the particular substance. The different physical and chemical properties with respect to that of the elements. The next we are having, now for example, let's discuss this one, different properties. We are having three substances. What's this? So it's carbon, sulfur, and carbon disulfide. As you can see, carbon, it's a black solid. Sulfur, it's a yellow solid. So it's a black solid and yellow solid. These are the physical properties. So when these two substances are made to react and the compound formed, as you can see, the compound formed is a liquid. Neither it's black, neither it's yellow, but a transparent liquid with a yellowish tinge. So this states that the compounds, their properties, the elements of the compounds, their physical properties and chemical properties are totally different with respect to that of the individual elements. The next we are having definite melting and boiling points. That means very sharp melting and boiling points. For example, melting point of water. Over here, I have written melting point of water. That means we have to consider, that means it is solid water. So melting point, I haven't written ice intentionally. So melting point of water equals to 0 degrees Celsius. That means we have to consider melting point of solid water. That is ice. That's 0 degrees Celsius at STP. Aluminium, it is 660 degrees Celsius. That also at STP. The next we are having chemical methods required to separate elements from a compound. So physical methods will not work. So we need chemical methods. We need to react a particular substance with another one, and then after few reactions we will be able to get back after few reactions, and for example temperature changes, pressure changes, we can get back the original elements which made the compounds. The next we are having atoms. let's discuss that one in a more detailed manner. Atoms of elements have combined by a fixed ratio by mass. What does that mean? That means when the two substances, two elements will combine, or three elements will combine, they will have a certain proportion. That means 1 gram of this particular substance or 1 gram of substance A will react with 1 gram or the 2 grams of substance B, and will react with 3 grams of substance C. Then only the required or requisite product can be expected. Okay, so they will react in a particular proportion. Fixed ratios will be there. But ratios of what? Ratios of mass. Let's consider carbon dioxide. Okay, carbon dioxide is having 2 oxygen atoms and 1 carbon atom. So 2 oxygen atom and 1 carbon atom. As you can see in the molecule also, 1 carbon atom and 2 oxygen atoms. So carbon is having an atomic mass, that means 1 atom of carbon is having a mass of 12 AMU. Now AMU is the atomic mass unit, which is the unit to express atomic masses of elements. So carbon, its atomic mass is 12, and for that of oxygen, the atomic mass is 16. So carbon, the atomic mass is 12. I repeat, what is atomic mass? The mass of 1 atom of carbon. Okay, so that's the atomic mass, the mass of 1 atom of the carbon. So mass of 1 atom of oxygen, that's 16 AMU. That means atomic mass unit. Now if we ratio of carbon mass to oxygen mass, that means 12 is to 32. Why 32? 2 oxygen atoms are there. So if 1 oxygen atom is having a mass of 16, then 2 oxygen atoms will have a mass of 32. So 1 atom of carbon and 1 atom of carbon and 2 atoms of oxygen is giving you a ratio of 12 multiplied by 30. 12 is to 32, which gives us the ratio that 3 is to 8. So the conclusion is, when carbon dioxide, carbon and oxygen, they are having a mass share of 3 is to 8. So 3 parts will be the mass of carbon and 8 parts will be the mass of oxygen. Another example, ferrous sulfide. Ferrous sulfide, the formula is FeS. As you can see, the ferrous sulfide is basically a black solid. Now once again we will follow the above procedure of calculating the mass ratio. That is, iron, the atomic mass is 56 AMU. Atomic mass of sulfur is 32 AMU. Right? So the mass ratio of iron is, I made a mistake over there. Please do consider that one. I made a mistake over there. Ratio of carbon mass to oxygen mass, that will not be. It will be ratio of iron mass to sulfur mass. Ratio of iron mass to sulfur mass is 56 is to 32. You remember ratio proportion. Probably you have read that one also, ratio proportion. You have done that one also, ratio proportion. So iron mass is to oxygen mass, sulfur mass. So 56 is to 32. And what's the mass ratio? Mass ratio is 7 is to 4. So 7 is to 4 means mass ratio. That means 7 parts of, that means when this iron and sulfur will combine together, they will react together to form the compound, then definitely within the compound, ferrous sulfide, 7 parts of the mass contribution will be from iron, and 4 parts of the mass contribution will be from sulfur. Okay? So with this mass ratios and the explanation about the compounds, I would like to put an end to my class over here. So that's all for today's lecture up till compounds, and thank you so much, and stay home and take a very good care of yourself. And for any further queries, you are most welcome to contact. Okay, thank you.